Hi, everyone. Today I'm going to walk you through an enablement on container scanning and scan results policies. I'm going to take a few steps back to try and make sure all of you have the same foundational understanding of these features in GitLab, no matter what your experience level is. Now let's get started. For today's agenda, we'll go through container scanning. What is a container image, and container scanning? Why do you need container scanning? And then how do you implement container scanning within GitLab? For our second topic of the day, we'll go through scan result policies. We'll go through what are scan result policies, why do you need scan result policies, and how do you implement scan result policies in GitLab. Let's start with container scanning. I've broken up the what is of container scanning to 3 sections. What is a container? What is a container image? And what is container scanning? So let's start with what is a container. Before we share what container scanning is, we must first define a container in the context of GitLab. A container is a standard unit of software that packages up code and all of its dependencies so the application runs quickly and reliably from one competing environment to another. For example, one developer's laptop, an on-prem server, all the way to a Kubernetes cluster. The best analogy for understanding containers is a shipping container. That's why the majority of all software container articles and blog posts show a photo of a shipping container. I'm sure everyone has seen an image of those big steel shipping containers, and the shipping industry standardized on a consistent size container. Now the same container can move from a ship to a train to a truck with the same cargo, but transported differently. Just like a shipping container, a software container is a standardized package of software. Everything needed for the software to run is inside the container. The software code, runtime, system tools, system libraries, and settings are all inside a single container. So what's a container image? A container image is a lightweight, standalone, and executable file format or package that includes all the necessary software components and dependencies required to run an application. It provides a consistent runtime environment that can be easily moved between different competing platforms and infrastructures. Container images are typically created by developers and contain the application code, runtime libraries, system tools, and settings required to run the application, such as Nginx on this slide here. They are designed to be portable and can be shared across different environments, making it easier to deploy and manage applications. Container images are used by container engines, such as Docker, to create and run containers. It is important to note that the container image that GitLab analyzes and uses is based on the open source technology called Docker. So you'll often hear container image and Docker image used interchangeably when talking to GitLab customers. The container image example I'm most familiar with is a website, which everyone should be able to relate to. A container image can contain everything that is needed to run a simple website consistently without worrying about the different environments it might run on. Multiple developers that might need to collaborate on building a website really need a consistent method to run the application without impairing their ability to see the same thing. The front-end developer might like working on Mac OS, but the back-end developer wants to develop on Linux, and they both need to deploy their image to a Kubernetes cluster on Google Cloud. It solves the classic problem of works on my machine, but not anywhere else. So what is container scanning? Container scanning checks your container images against known vulnerabilities that may affect software that is contained within. Users often use existing images as the base of their containers. It means that they rely on the security of those images and their pre-installed software. Unfortunately, as the software is subject to vulnerabilities, this may affect the security of the entire project. Container scanning is often considered part of software composition analysis, SCA. SCA can contain aspects of inspecting the items your code uses. These items typically include application and system dependencies that are almost always imported from external sources, rather than sourced from items you wrote yourself. In this walkthrough, a GitLab pipeline with a container scanning job has already been completed. As a result, I'm able to view any vulnerabilities found by the container scanning tool via the vulnerability report in GitLab when it analyzed the container image that I was building for my project. This vulnerability is an outdated version of software that was included as part of the container image and needs to be updated to a later version. The important takeaway here is that container scanning allows customers to validate that all of the software that's needed to run in their applications in a container are secure and free from any vulnerabilities. On this slide, I just wanted to drop some of the names here of our competitors who provide similar tooling to our container scanning. It's helpful to recognize these names when doing discovery with a customer about their DevSecOps toolchain and trying to understand their readiness to consolidate on GitLab. So another thing to note here that container scanning is frequently bundled together with dependency scanning and license compliance to provide an overall software composition analysis solution, or SCA, within the application security testing market. GitLab was recently named as a challenger in the 2021 Magic Quadrant for application security testing. Container scanning is available to both our free, premium, and ultimate customers. The primary difference is the customer's ability to perform vulnerability management natively in GitLab, as you can see from this table pulled directly from our documentation. Another key difference is that in Ultimate, the customer gets all of the latest vulnerability content from the GitLab advisory database immediately, whereas the free or premium tier has a time-delayed database which contains all advisories from the GitLab advisory database that are older than 30 days, as well as specific vulnerabilities that have the potential to become widespread and cause disruptions to the entire internet. And those are pushed immediately. So how do you set up container scanning in GitLab? There's two ways you can do it depending on your persona. For developer teams, you can enable auto DevOps, which includes auto container scanning. You can also edit the GitLab CI YAML file manually, and I would recommend using this method if your GitLab CI YAML file is complex or already in place. And then finally, you can utilize the UI to simply add the appropriate snippet to enable container scanning to your GitLab CI YAML file. And this is really useful if you're just getting started and haven't really built out a complex GitLab CI YAML file. So these are all for development teams that want to add this directly to their project's pipeline. But for security and compliance teams, you also have the ability to enforce container scanning through a scan execution policy or through a compliance pipeline. We've got links to all of these directly on this slide deck that you'll be able to access after this presentation. Next, I want to talk to you about scan results policies. So what are scan result policies? First, we need to talk about security policies. Security policies allow users to use a simple UI to define rules and actions that are then enforced. Security policies themselves are fully audited and can be configured to go through a two-step approval process before any changes are made. All policies are supported at the group, subgroup, and project levels. Next, we have scan result policies. Those scan result policies are a type of security policy that allows users to enforce approval on a merge request when policy conditions are violated. Currently, criteria related to both security and license scanners are supported. For example, users can require approval on merge requests that introduce newly detected critical vulnerabilities into the application. So why do you want to use scan results policies? So the primary value driver for our customers that we want to share with them is to enforce strong security and legal compliance. Enforcing strong security and legal compliance to help encourage adoption of scan result policies is a way to ensure appropriate oversight across an entire organization's software development projects to reduce overall risk. So with security approvals and license approvals, it allows your users to select the conditions that must be met to trigger the security license approval rule, including which branches, scanners, vulnerability count, vulnerability severity levels, and/or which licenses are expressly allowed or prohibited from being present in the MR. If all those conditions are met, then the merge request is blocked unless an eligible user approves the MR. This extra layer of oversight can serve as an enforcement mechanism as part of a strong security or legal compliance program. Another value driver is to consolidate the DevSecOps workflow. GitHub offers a capability that is similar but is more limited. So consolidating the DevSecOps workflow is another value driver to help encourage adoption of scan results policies as a way to bring security and compliance teams closer to the software development process. Many other security tools will comment directly in a merge request showing the vulnerabilities detected, but because they're a separate tool from the SCM in GitLab, they're usually not able to actually prevent the MR from being merged. So with the combination of GitLab security scanners and security and compliance policy management, customers can displace customers can displace using tools like Sneak and GitHub as an integrated solution to consistently prevent vulnerabilities from being merged and deployed to production. So how do scan result policies work in GitLab? This is an example of a scan result policy focused on security, and specifically secret detection. So you can use scan result policies to take action based on scan results. For example, one type of scan result policy is a security approval policy that requires approval based on the findings of one or more security scan jobs. Scan result policies are evaluated after CI scanning is fully executed. Once your policy is complete, save it by selecting configure with a merge request at the bottom of the editor. This redirects you to the merge request on the project's configured security policy project. If the security policy project doesn't link to your project, GitLab creates such a project for you, and existing policies can also be removed from the editor interface by selecting delete policy at the bottom of the editor. Most policy changes take effect as soon as the merge request is merged, and any changes that do not go through a merge request are committed directly to the default branch may require up to 10 minutes before the policy changes take effect. So in this example, we're creating a policy called no secrets allowed, and we're making sure that if the security scan from a security detection job finds more than 0 critical vulnerabilities in an open merge request targeting any protected branch, then we require approval from one of these required approvers, presumably somebody from the security team. On the right-hand side here, we've got the merge request that shows the secret being detected. It's a critical vulnerability, and it's automatically added this approval rule for no secrets allowed in this policy to make sure that this certain approver has the right oversight on this secret that's been detected, and make sure that the merge is blocked before this person can approve it or not. Ideally, the secret would be revoked and then removed from an upcoming an additional commit to this feature branch, and then the merge would no longer be blocked. Another example of a scan result policy is the license approval policy shown on the screen. This requires approval based on the detection of specific licenses used by project software dependencies. Here, we're enforcing a strong legal compliance program by making sure a specific license is not allowed to be merged in any merge request without oversight and approval by specific members of the team. So we want to make sure in this license approval policy that if the license scan finds any license matching this specific license that we're not allowed to use from a legal standpoint, and it's newly detected in that open merge request targeting the main branch, then we require approval or oversight from Sam White here. So once we've created this new scan result policy focused on license compliance, we can see that in action here in this merge request on the right-hand side. So with this merge request, we've added a new dependency that introduces this new license that we want to block that's being detected as part of the scan result policy. It says that it's been denied here. So it's being flagged that we are requiring approval from Sam White and the merge is blocked. So ideally, Sam can comment in the merge request asking to remove this dependency or find a suitable replacement that doesn't have that license attached to it, and then make that change on that same feature branch for another review, and making sure that we are compliant with this license compliance rule. It's important to note that scan results policies are only available on GitLab Ultimate and not available on GitLab Free or Premium. So how do you set up scan results policies in GitLab? We've already shown you that process through the editor. But enabling scan results policies are fully in the realm of the security and compliance teams of our customers, just to ensure that specific rules are in place to prevent vulnerabilities from being introduced to the organization's software without prior oversight and approval, as well as reducing legal risk by preventing specific software licenses from being introduced without prior oversight and approval. It's important to note that developers will not be adding any configuration to their project's GitLab CI YAML file to ensure a scan result policy is in place. So everything happens through the creation and editing of a security policy project, which can be facilitated through the policy editor if that project doesn't already exist. So as a recap, we went through what is container scanning and scan result policies. We talked about why container scanning and scan result policies are important. And finally, we talked about how container scanning and scan result policies are implemented within GitLab. Thanks again. Have a great day.